So now that we've done this, we can kind of start looking more at our structure of our if statement. And we showed the if statement before. This is the general form. We're going to discard this very quickly to go into an extended form. But the general form of an if that you see in almost every language is there's if, there's a condition. The condition is a Boolean, right? It's something that evaluates to true or false, right? So oftentimes this is a relational. When we go back to our code, right up in this window, right? This part is the condition. And it's a relational that asks the question, is Chris's height greater than Sandy's height? If the condition evaluates to true, we execute the block right under the if. If it doesn't, if it evaluates to false, then we execute the else block, right? So if it's false, we have this little flag here that gets executed, and that's block 2. Now, the only thing you really need is the if, right? If statement has an if keyword. It has a conditional. This is something that evaluates to true. You can use the variable, or you can use the value true or the value false in here if you want, but then you're getting rid of the whole purpose of the if in general. It'll always go down one path. And then after that, you have the colon. And then just like with our functions, we indent some number of spaces. I generally do 4, sometimes 2 if I have a lot of convoluted code. And then in this indent, in this block 1, this is 0 or more lines, or 1 or more lines of Python code. Can you have 0? You may be able to have. I'll check that. But you have your block of code that you want to execute if the condition is true. Then optionally, you don't have to have an else, but if you have an else, you have the keyword else followed by a colon, and then a block of code that gets executed if the condition is false. So if we go back to our example, right, this is the condition. In this particular case, it's a relational that relates Chris's height to Sandy's height. If that evaluates to true, this block gets executed. If it's evaluated to false, this block gets executed. And then after we put our indent back, right, this can be as many lines as we want. Print 7. Right, after we've printed as many lines as we want, we can do the same up here, right, as long as we maintain the indent. Print 2. Okay. After that, we drop back down. We kill our indent. We come back down here and we print all, something like that. Okay, so we can run this again, and I will say 1 and 3. They're very short people. If 1 is 3, Sandy is taller at height 3, so we print a couple 7s, and then we print all. And if we run it again, and this time make it 3 and 1, or 2 and 1, Chris grew a little, Sandy shrunk a bit. Then we go into this block. We execute all of these lines till the indent ends. We skip over the else block, right? We skip over block 2 and then hit the all. So that's kind of the flow of control. It gives you 2 optional paths to go in, depending upon what the relational in our condition evaluates to. Okay, I've been kind of saying this, that it's awfully close to what we have, that this else block is optional. So let's take the else block out. I'm going to continue with this, Chris and Sandy, but you can get to what is in that. You know what? Good programmers are lazy. I'm going to be as lazy as possible. Right, this has exactly the same form as what we had up there. Let's do max H equals Chris height and we'll take this down here and we'll do that, and then we'll get rid of these garbage lines. And this should look a lot like what you're seeing down below. And now we can just come down here, and instead of printing out all, we'll just print out max is max H. Okay, and what this will do is it's going to set up two optional blocks, right? The first block, if Chris will only get triggered if Chris is taller. The second block will only get triggered if Sandy's taller. And we should cover the case where they're equal. And where they're equal, we'll say tie goes to the Sandy. Right? Tie goes to Sandy. And we can run this. And, you know, we can do the same thing we did before. 3 and 1. Chris is taller. Oops, this should be less than. Ha, sorry about that. But that does kind of illustrate something I'm going to talk about in just a second. Run this again with the correct code, 3 and 1, right? Chris is taller. The maximum height is 3. Run it 1 and 3. Okay, Sandy is taller. The max is still 3 because I have a very unimaginative fingers. So this is the same as having the else. So the else is optional, and we can achieve the same things by having independent if statements. Now, the reason we may not want to have independent if statement is it's really not a good coding practice. If this condition is orthogonal to this condition, then you want to capture that relationship in this if-else clause, because an if-else clause, at most one of these, right? In an if statement with an else, at most one block gets executed. So the orthogonality, the fact that both of these conditions can't be true at the same time, is supported by the syntax of the operation, right? The other way, the code is, oops, doing the wrong thing. Right, this code gives you the correct result, but it's not as clean because we're not supporting, we're not demonstrating that these two conditions are orthogonal. And we could end up by making a mistake, something like I did before with the greater than sign, and now they're no longer orthogonal. We're going to fall into both of these whenever Chris is taller, and neither of them when Sandy's taller. Okay? Does that make sense? Sure. Mm-hmm. Yes. As the correct case. Right, as this. Yeah. Because these are orthogonal conditions, even though we haven't used, even though you have to read the code to know they're orthogonal, they are orthogonal. You can't be greater than and both greater than and less than or equal to. Right? It has to be one or the other. Okay? You're welcome. Okay, and you'll notice that every now and then I have blank lines in there. Blank lines don't matter in Python. They are just for stylistic elements. I like to break up sections of code using blank lines. Hopefully you will too. It makes code more readable, but they don't really have any real meaning in Python. All right. So now we get to our fun case. Why does Sandy get all the love? Right? When they're equal, we ought to say they're equal. The problem is that gives us 3 cases, right? Chris is taller. get my finger in the picture. Sandy's taller, or they're both the same height. And we can't do that with an if and an else. So what did we do? We invented another one. So what we can do instead is, let's go back to our, well, let's start from here. And let's write this. So now we have Chris taller in the first one. We have Sandy taller in the second one. And now if Chris height is equal to Sandy height, right? Because now we're missing that, right? If they're both the same, we don't execute this. If they're both the same, we don't execute this. So if they're both the same, now we want to execute another piece of code. And we'll just steal a little bit. Since they're both the same, it doesn't matter which one we set to max H. We may as well leave it as Sandy. It's the same value. And we can say something like neither is taller. Okay, so now we've captured the three cases. And this should actually work, I hope. Right, so we can say, 1, 3, Sandy is taller. Run it again. One of my big annoyances with this system is that I have to keep mousing over into this window to enter stuff. Okay, so 3, 1, Chris is taller. Run it again. Let's say Sandy's grown up a little bit. Now it's 3, 3. Neither is taller, and the max is still 3. Okay, so now we've captured this, but we've lost the relationship. There's no idea that these are 3 orthogonal conditions. And so if we want to enforce the fact, if we want to show that these are 3 orthogonal conditions, well, we have a different construct. And it's pretty much the same construct, but just slightly different. Right? Instead of an else, we have an elif. And then down here on the if, we have the else again. And the else is the catch-all state, so we don't need anything there. Okay, and what this says is the first thing that happens is you come through and you execute the if. If this conditional is true, you execute this block and then come down to the max is part. Okay, you don't evaluate anything else if this is true. If this is false, you come down to the first elif clause and you test that. Okay. If this evaluates to true, then you execute this block. And if neither one of those are true, then you come down and hit the else block. And by the way, you can have as many elifs as you want, right? You can have, elif red equals blue, for example. Right, so you can have as many elif blocks as you want. But the important thing is, that only one of these blocks, when you have an if-elif structure, only one of these blocks is going to get executed. And it's the one that evaluates to true first. If no one evaluates to true, there's an else. And by the way, the else is optional. So if the else isn't there, then there's the possibility that none of the blocks will get executed. The else is the catch-all if it's there. If no one else evaluates to true, the else evaluates, the else block gets executed. If the else block isn't there, then there's the possibility of dropping through the if statement without executing any of the blocks. We will run this. We'll do our 3, 1. Chris is taller. Max is 3. We'll run it 7, 12, maybe. 7, 12. Sandy's taller. The max is 12. We'll do one more. 1,000 and 1,000, and they should come out to be the same. Okay, so this is another structure. Just looking at the syntax of the elif, right? This is what it looks like. You know, we have an if with a condition and a block. An elif is the keyword, another condition, the colon, and then a block, and then the else, colon, and then block 3. There can be as many elifs as you want in there. There can only be one if, and there can only be one else. All right. And yeah. Okay, so we are actually doing almost okay. You guys holding up there? Checkpoint 3 is required for Lab 1. It's not required that you submit it to Submittee. Slowly dying. Come on, man. This is the fun stuff. Checkpoint 3 is not required to be submitted to Submittee for checking. It is required for your submission to get credit, okay? All right, let's talk about and, but, and, or at least and and or. We have no buts. So we get into this more complex Boolean expressions. And or. Am I supposed to do a... and or and not? There we go. Okay. So we have true and false, right? So true is true and false is false. Double ampersand is the and operator, and is true only if both its arguments are true. I am sorry, I think I just slipped into C++. Or C, either one. There we go. True and false. And is true only if both arguments were true. So true and false is false. False and false is false. False and true is false. You get the picture? The only one that actually gives a true is a true and true. And truey is not a name. Okay. Right? So if we have 3 less than 5. Oh, I'm sorry. Yeah, I can't. I don't even have to have that. In fact, let me turn that off. That's just there so you guys feel like I'm here as opposed to a robot. Good point. There we go. Better? As you can see. Okay. So, 3 is less than 5 and 4 is greater than 7. Right? True, false. So this should be a false. And that's kind of how you use the and. You have a conditional on one side and a conditional on another side, and it will tell you whether they're both true. Okay? Or is similar, except or's kind of like the polar opposite. And is very picky. Both the values have to be true for an and. Or true or false is true. False and false is false. False or true is true, and true and true. True or true is true. Okay, so false is kind of the opposite. In order for and to be true, both sides have to be true. In order for or to be true, either side can be true. And or is a little bit different too than, and so let's kind of illustrate this part. You know, there's a thing in your notes that say if you're at a restaurant and you know you're at a Cracker Barrel, for example, and they say you can have pancakes or sausage with that, or pancakes or waffles with that. That generally means you have to have you can have either one of those, right? So that is called an exclusive or XOR. This is an inclusive or, and it's an inclusive or because it includes the true or true state. So just keep that in mind, that true or true will always evaluate to true. It's not how you would normally use an or in general conversation. It's how you would use an or in logic. This is the inclusive or. The one we normally use when talking is an exclusive or. And the final one we want to talk about is the not. And you can put not around anything. And if the value you're applying the not to is true, it comes back false. And if it's false, it comes back true, right? And we can make this about, not false and false is going to be false. Let's make sure we're evaluating that correctly, right? False and false. This within the parentheses evaluates to false. So not of a false is a true value, whereas the original one is more like which evaluates to true and false. True and false is false. So true not changes it. Whatever it was becomes the opposite. So in this case, not false evaluates to true. True and true is actually true. All right. We've got about 10 minutes. Let's at least sketch out our point inside a rectangle code. Let's see. So here's my whiteboard. And what we have, here's the case we're looking at. We have an axis, right? This is X. This is Y. Wow, that Y is awful. That's Y. Okay, and now we're going to draw a rectangle there. And our rectangle is going to have horizontal lines and vertical lines. And the horizontal lines are going to go between Y0 and Y1. And the vertical lines are going to go between X0 and X1. Right? So this point here, for example, is X0, Y0, and this point up here is X1, Y1. And we want to ask the questions. We're going to ask the user to input a value X and Y. And we're going to ask the question, is X and Y in the triangle? Or in the rectangle? Outside of the rectangle? Or on the green bar along the edges? So, where do we want to start? I'm going to steal the code for setting this up just to save us a little bit of time. Right, so this code, nicely written, is in code written in class. I'm going to come in, I'm going to create a new window, and I'm going to paste that in. And this should come through and ask us for X and Y values. 7, 12, yeah. Okay, so now what we want to do is we want to, going back to our whiteboard, we want to make a decision. And we can decide in whatever order we want, but we know we have to make 3 decisions, so we're going to want an if, elif, else kind of setup. So let's look first at, well, let's say we want to figure out the black area. Is x and y in the black area? Is it in the interior of the triangle? Right? Well, for x to be in the interior, x is only in the interior, the point xy, let's call that P, is only in the interior if x is between x1 and x0. So x0 is less than x1. And y is also between y0 and y1. Okay, and this is a different order than I wrote it last time. I'm not going to change it in the code, but I do like changing the order so that you guys can see multiple ways of doing it. So in order for it to be in the black area, we have some very simple tests to write. Right? So we'll start off with our if. What did I want to print on this? Okay, I'm going to simplify the prints as well because we got about 4 minutes. So we can say if x, and I'm going to use parentheses, yeah. If x is less than x1 and x is greater than x0, right? Because it has to be between x1 and x0. Less than x1, greater than x0. And we have to do the same things on y. Y is less than y0, y1. And y is greater than y0. So now we have a whole bunch of conditions strung together, but basically they're answering this question we're posing here. And by the way, there is a shorthand for doing this that will teach you, I think, in a couple of lessons. But basically we want x to be greater than x0 and less than x1, and y to be greater than y0 and y to be less than y1. And that's all this statement says, right? X has to be less than x1, greater than x0. Y has to be less than y1, greater than y0. And if that's the case, we can come down here and say print interior. And like I said, I'm taking some shortcuts. Okay. Now the second one is, well, let's do the outside case. Right? So now we're looking at the blue area. And for the blue area, I dropped my blue pen, so the blue area is now going to become, yeah, I can pick it up. Okay. So now for the blue case, right, if x is less than x0, then we're out here. If x is greater than x1, then we're out here. Ah, thank you. That's what happens when we run out of time. We get excited. Okay, so if x is less than x0, then we're out here. If x is greater than, or, right, this is a, then we're out here. And similarly with y. This is y less than y0. And this is y greater than y1. And if any one of those conditions are true, then we're in the exterior. So for the first one, all the conditions had to hold in order for us to be in the interior. And for the second one, if any of those conditions hold, we have to be on the exterior. So we can write that as elif y less than y0, or y greater than y1, or x less than x0, or x greater than x1. Right? If any of those occur, then we're on the exterior. And now we've actually defined everything, because we have the inside and we have the outside, so we can just come in here with an else and say print boundary. Okay? If we wanted, we could do more details and we could actually put in another elif to do the boundary. That's in the code, so you can see how that one actually works. It's probably the most complicated case. But you guys can take a look at that because we are out of time, and I will run this as you guys are leaving, I think. Oh, wrong window. Okay. So 10:37 should be on the boundary, right? Because we've matched this. X isn't bigger than x naught or less than x naught. If we run it again, we're on the interior. If we run it again, we should be on the exterior. Okay, so that's all. You guys can head out. I'll stick around for a little bit longer and answer some questions. But another version of this code is actually posted here. Essentially, this clause is our interior clause. That's the one we have first. You can't see that because this is not switching. There we go. This clause is our interior clause, and the else was for the exterior. And this is the clause for being on the boundary. Make sure you can understand that, the boundary clause. All right? Enjoy.